Hello, Lightning Leaders! It has been a while since I have made a math video for you, and I'm actually kind of excited to put this together. So I've been looking at your scores and your tower activities on Zern, and the number one thing that keeps popping up is something that's taking more than one try, maybe 2 or 3 times, to complete the lesson, is this whole fractions greater than 1. Now, this is something we never really got to in the classroom, which is why this is some new learning stuff. And I'm getting the feeling that the Zern video really isn't doing the greatest of job, so I wanted to record this video as if you were in class with me and I was saying the things I would have said in a normal math lesson. I actually have our math lesson pulled up on my computer that would have been taught with this skill. So we're going to talk about it today. I'm actually going to do 2 lessons in one. We're going to do mixed numbers into improper fractions, and then we're going to go backwards. We're going to go improper fractions into mixed numbers. And I went through all the skills and strategies that are there to do, and I think I picked out a couple that are the nicest to understand and build off of the skills that we already have and have been working with for the past 2 years in math, dating all the way back to the beginning of our fractions unit in 3rd grade. So with that said, we're going to work together here to convert 7/3 into a mixed number. Now, the difference between an improper fraction and a mixed number is that a mixed number has a whole number mixed with a fraction. That's where it gets its name. An improper fraction is a fraction where the number on top is bigger than the number on the bottom. The numerator is bigger than the denominator. And that's how you know you have an improper fraction. So what we're going to do here is we're going to see what this number is as a mixed number. We're basically coming up with an equivalent number, an equal number. Our answer is going to be the same amount, same size as what we started with. Now, to do that, I need to start thinking about a couple things. First of all, I know that 7/3 is bigger than one whole thing. If I'm chopping things into 3 pieces, and I have 7 of them, that means I have more than one. If I have 7 pieces, I have more than one complete thing, because if 3 pieces go into one thing, well, then I still have some extra pieces left over. So I need to think to myself, okay, thirds, 3 pieces. The whole was cut into 3 pieces. So that means I have 3/3, and if I had another full thing, that would be 3 more pieces, which is 6/3. And then if I had another 3 things, that would be a 3rd full complete thing, and that would be 9/3. Oh, I've gone too far. 3, 6, 9. 9 is bigger than 7. So that means, knowing that we only have 7, I can take out 2 whole numbers because 3 pieces was 1, and 6 pieces was 2. So what I'm doing here is I am taking out 3/3 and another 3/3, and that's going to leave me with 1/3 left over. Now, Mr. S, where are you getting these numbers from? Well, what is 3 plus 3? 3 plus 3 is 6. What's 6 plus 1? 7. 3 plus 3 plus 1 is 7. And our unit is thirds, so that's not changing at all. It's just like we're talking about with any other thing with units. The units have to stay the same, and the units have to be the same in order for any of this math to work. I can't take apples from oranges. I can't take pens from pencils. I can't compare miles and meters. They're not the same thing. Thirds is our unit. It's written differently than we're used to seeing. Instead of being a word next to our number or a symbol next to our number, we have this line and another digit underneath. That's what's really confusing about fractions, is they just look so much weirder than anything else we do in math. Now, I have this crazy looking number bond here with three legs on it. I'm going to actually combine this and make it a little smaller, because when we were doing our skip counting by thirds, 3/3, 6/3, we saw we could take 2 whole things away. So I'm actually going to combine my 3/3 here and 3/3, and I'm going to make this into 6/3. So now I have 6/3 and 1/3 taken from 7/3. Now, we know that 6/3 is 2 complete things. 3/3 was 1, another 3/3 is 2. So this right here is actually the whole number 2. And then we still had this 1/3 here. So we need to carry that along with us. And now we have our mixed number. 7/3 is the same as 2 and 1/3. This fraction, this improper fraction, is the same amount as this mixed number. Mixed number, improper fraction. If we were to draw this as a picture, I'm going to draw some quick rectangles here. There's some thirds, some more thirds, and I'm going to shade in 7 of them. If we look, this is showing the same thing. 1, 2, 3, 4, 5, 6, 7. 7 pieces. Each of the complete things is made up of 3 pieces. That's exactly what this fraction says. This picture shows it. If we look down here, 1 complete thing, 2 complete things, plus a third. 2 complete things, plus a third. So this is how we took our improper fraction greater than 1, and actually this one was greater than 2, and we turned it into a mixed number. Let's do another one right now. I'm going to erase my whiteboard here. So glad I snagged this out of the classroom the last time teachers were allowed to go in. All right, our next fraction here is going to be 13/5. And I hope I didn't write that too big and I don't run out of space here, because that would not be good. Let's think about this. This fraction right here is telling me that I have 13 pieces, and each of those pieces is 1/5. I have 13 1/5s, because that is my unit. Now, since my unit is fifths, that means it's going to take 5 of those pieces to put something together, to complete something. So let's count by fifths until we go farther than 15. Now, to count by fifths, or to count by whole numbers in fifths, it really means we're counting by 5s, because there's 5/5 in one complete thing. So we have 5/5, 10/5, 15/5. Oh, we went past 13. 15 is too much. So we are between 2 complete things and 3 complete things. We need to figure out where we are in that number line. So let's think here. Let me grab my black marker. We figured out that we could go at least 2 complete things. 5/5, 10/5. So I can take out 10/5 from this number bond. Now, if I took 10 out, 13 minus 10 means that I have 3/5 left. So here is my number bond now that I've broken up my 13/5. This is my whole number. This is my fraction. We counted and found out that 5/5, 10/5 was 2 complete things. It is a whole number 2. And then we just carry over our fraction. So now we have our answer. 13/5 written as a mixed number is 2 and 3/5. I'm going to do one more. I'm going to do one more here. And that one is going to be 35/10. All right, let's start with our steps again. I know that I have 35 pieces, and each of them are the size of 1/10. I have 35 1/10. I have 35 tenths. Because my unit is tenths, I know that it's going to take 10 pieces to put one whole complete thing together. So I'm going to skip count by tenths until I get past my 35 to see what whole numbers I'm going to fall between. So let's see here. 10 tenths, 20 tenths, 30 tenths, 40 tenths. Oh, I went over. So I know I'm between the whole number 3 and the whole number 4. So if I pull out 3 whole numbers, that would be 10 tenths plus 10 tenths plus 10 tenths. 10 plus 10 plus 10 is 30. So I'm taking out 30 tenths. I took out 3 whole numbers. 10 tenths, 10 tenths, 10 tenths. Now if I do 35 minus 30, I'm left with 5 tenths. We already found out that this is 3 whole numbers. 10 tenths, 10 tenths, 10 tenths. So this mixed number is 3. Oh, that is a nasty looking 5. I don't know what happened there. 3 and 5 tenths is our mixed number. So this was our part of the lesson where we were converting our mixed numbers to improper fractions. I hoped my little explanation here helped clear up some of the confusion you may have been having from the Zern lessons. What we're going to do now is we're going to switch gears and we're going to go backwards. We're going to turn these mixed numbers into improper fractions. So let me flip over my notes here so that I can see my example problems. And I'm going to switch the lesson plan over on the computer. All right. Yeah, no, we're not using a number line. That's absolutely nasty. Okay. Let's look here. Here is our first example. We're going to turn 2 1/6 into an improper fraction, which means we're going to go from having a whole number and a fraction to having just a numerator and a denominator. But the numerator is going to be bigger than our denominator. And our denominator is going to be 6. That is not going to change because 6 sixths is our unit. That is our unit of measurement. Everything we're talking about here is the size of 1/6. So let's start diving into this. How do we turn this into an improper fraction? Well, there's a couple ways to do this. The first way I'm going to show you is with a number bond. The second way I'm going to show you is a little bit more complicated, and you should stay away from if you have not mastered your multiplication facts. And I would suggest that you stick with this number bond method. So let's start with the number bond method. So we all know a number bond. We're going to break this thing up into 2 pieces. Now, I'm going to bring my 2, my whole number, over here. And I'm going to bring my fraction, my 1/6, over here. Now, what I'm going to do to this 2 is I'm going to turn it into a fraction. Well, Mr. S, how do you do that? Well, do we know how many sixths it takes to have one whole complete thing? If this was 0 and this was 1, how many sixths fit in between here? Well, yeah, we do, because it takes 6 sixths to make 1. So let's see here. Let's count by sixths until we get to 2. 6 sixths, 12 sixths. Oh, so I can rewrite this whole number 2 as 12 sixths. And then all I have to do is add in the 6 that we brought along the whole way. And now I know that 13 sixths is the same number, the same size as 2 1/6. It's the same thing written 2 different ways. Don't ask me why, it's just something we do. Now, the second way to do this is a little shorter, but not as easy to see. But you might see the pattern here. The other way to figure out how to turn this mixed number into an improper fraction is to take the denominator and multiply it by the whole number. 6 times 2 is 12. Then you take that number and you add it to the numerator. 6 times 2 is 12. 12 plus 1 is 13. 6 times 2 is 12, plus 1 is 13. That is the math that we just did to figure this out. I'm going to do another example question using the number bond right now. Let's see here. Let's talk about, let's do 4 2/3. 4 2/3. So we're going to break this up into the whole number and the fraction. Now I have to think to myself, how many thirds are in the whole number 4? Well, to get there, I need to know how many thirds are in the whole number 1. So let's see. One whole thing has 3 thirds. 1/3, 2/3, 3/3. 3 thirds equals 1 whole. So now I need to figure out how much 4 of those would be. Well, let's skip count by thirds. 3 thirds, 6 thirds, 9 thirds, 12 thirds. Now I know that 4 complete things is 12 thirds. So I can rewrite this 4 as 12 thirds. And then I need to add in the fraction that's been coming along for the ride to find out that my improper fraction is 14 thirds. 4 2/3 is the same as 14 thirds. Now, using that other method with a lot less work here on the page and a little bit more mental math, 3 times 4, 3 times 4 is 12. 12 plus 2 is 14. 2 different methods to get the same answer. 2 different methods to get the same answer. 4 times 3 is 12. 12 plus 2 is 14. So this video was all about taking those mixed numbers, turning them into improper fractions, and taking those improper fractions and turning them into mixed numbers using our number bonds, breaking those fractions and mixed numbers apart so we can see their pieces, move them around, and figure this out. Now, this method is the final product. This is where we're building to. But in 4th grade, we're not there yet. We need to understand where this comes from before we can jump to this. Because jumping right to this is not going to solidify your understanding of math. Yeah, you might be able to just follow the procedure and plug this in and figure it out. But if you don't know why this works and how this works, you really don't know the math. And that's why we do this building block way. So we have a conceptual understanding of what we're doing instead of just spitting it out like a robot. We want to be thinkers, not producers. So this video was all about these mixed numbers and improper fractions. In my next video, the other trouble spot I saw was the subtraction of fractions greater than 1. So I'm going to make a video about that next. I hope this was helpful. A lot of you really are doing a great job with this, but this is if you need a little extra boost or a different voice explaining this stuff to you. So I hope this helps, and I will see you guys next time.